Hey, Algebra 1, we have been talking about sequences. In general, we've been talking about arithmetic sequences, and today was the first day we introduced geometric sequences. So if it's geometric, it's more of a sequence based on multiplication, or you may be multiplying by a fraction, which feels like it could be division. And so I'm going to make up a quick example. Let's say you start with 2. Multiply that by 3 to get 6, multiply 6 by 3 to get 18, multiply 18 by 3 you get 54, and that pattern could just continue multiplying by 3 for bigger and bigger numbers, and that would be called geometric because it's consistently multiplying by 3. And anytime you're not sure what something is multiplying by, we can find that common ratio by doing the second number divided by the first number. So for example, if I said 6 divided by 2, well, that would be 3. And really that should be true anywhere in the sequence. 18 divided by 6, 3. 54 divided by 18, 3. So just make sure you divide moving backwards to find that. So if I'm doing that for this one, I'm going to do the first few, and then I'll leave you 5 and 6 to demonstrate understanding. So in the first one, I noticed that 12 divided by 4 would be 3. And now the question is it consistent? Is it consistently multiplying by 3? So again, I did 12 divided by 4, which is 3. And so now maybe use your calculator or a sheet of paper just to kind of multiply some stuff out. 4 times 3 is 12. Times that by 3, times that by 3, and that is giving me all the other numbers. So yes, this is geometric, and that R value would be 3. Now 2 is more of a sequence about adding. It seems to be adding 5 over and over and over. So is it geometric? No. But I hope at this point you connect a vocabulary word with this sequence. It is arithmetic. An arithmetic sequence is a sequence that uses addition or subtraction to continue the sequence further along. Now, as a math teacher, the more difficult ones that I see students have problems with is like number 3. So the numbers seem to be decreasing. And so if I take that second number, let me make sure I get it right, the negative 60, and divide by that first number, 120, negative 0.5 or negative 1/2. So basically I am halving each number, and the signs are changing back and forth. So half of negative 60, 30. Half of negative 30, or half of negative 1/2 of 30, negative 15. So this one also is yes. And that common ratio would be negative 1 divided by 2. So let's look at another one. 1, negative 4, 16, negative 64. If we divide these first two numbers, negative 4 divided by 1, negative 4 divided by 1 is negative 4. And that is a consistent value that gets me throughout the sequence. If you keep multiplying by negative 4, the signs keep alternating, and that is correctly giving me every other value in the sequence. So that is also correct. So is 5 arithmetic or geometric or neither? What's going on with number 5? And then same thing with number 6. What's going on as those numbers are decreasing? Is it geometric? And if so, what's that common ratio? So let's try a few where you're trying to find the next 3 numbers. And so I'm going to start by saying the second number divided by the first number. And that tells me that in number 7, everything is multiplying by 2. So 16 times 2, 32. 32 times 2, 64. 64 times 2, 128. Similarly, in the next one, negative 6 divided by 1, that's negative 6. And so we're using multiplication of negative 6 to get throughout the sequence. So let's take that last number, 36, and multiply by negative 6. You get negative 216. We're going to multiply that by negative 6 to get positive 1296. And then if you notice, anytime in this calculator that you do the same action twice, so for example, I multiplied by -6, then I did it again. If I just press enter, it continues that idea of multiplication of -6, and that's -7,776. Okay, so I'm going to leave you a few more to do. I want you to try these on your own, and we'll kind of see how well you do. In fact, well, I think I'll do one more. I think I'll do number 11. Because that one seems a little challenging. Second number divided by the first number, that would be -1/2. So we are halving over and over and over. So I'm going to take 60 and multiply it by -1/2, and that gives me -30. And if you continue that, half of -30 would be +15. And then multiply that by -1/2, and that's -7.5. So I left 3 for you to try. You try 9, you try 10, and 12. So this is where the rubber meets the road, if you will. We really need to understand how to write an equation in order to find a future term. Find the nth term, find the 4th term, or the 10th term, or the 100th term, I don't know. But this one wants us to find the 9th term in the sequence. So I'm going to start by using the equation that I gave you in class, the first number multiplied by that common ratio value with the exponent n-1. So let's do it. I want to find a sub n. That's just kind of like your y equals or f of x equals. It's just kind of like explaining what it is. It's a sequence involving n as the input. And so the first number in this sequence is 5. To find the r value, you divide the the second number by the first number, and that one is 4. 5 times 4 is 20. 20 times 4 is 5. Let me say that again. 5 times 4 is 20. 20 times 4 is 80, and that will continue to give me the rest of the values multiplying by 4. Now I could just multiply 80 by 4 a few times to find that 9th number, but really the purpose of this is to create a formula so that you can replace n with the position you are looking for. And of course I'm looking for the 9th number in the sequence. So let's go 5 times 4, and 4 has a power of 9 minus 1. So it's a pretty big value, 327,680. So again, if you would just take your pattern, I've got 5 times 4 times 4. Here's my 3rd number, 4th number, 5th number, 6th number, 7th number, 8th number, 9th number. Okay? Sometimes we give you values that are way in the future. That's easier with arithmetic than geometric, because geometric is multiplication. It just gets so big so quickly. But specifically with arithmetic, you want to be able to build a formula so that you can input whatever you're looking for, because sometimes it's like the 1000th term, and that is not what you want to do. You don't want to use the calculator to actually find every number between the 1st and the 1000th term. Let's try another one. The first number is -2. If I divide 10 by -2, you're actually multiplying by a -5. And then there is my formula. n-1 is the exponent. It's just always the same. And now if it wants me to find the 9th number, let's go multiply -5, and then replace the n value with 9. So let's go for it. -2 times -5 raised to the 9 minus 1. And so that ends up giving you -781,250. So another reason why I want to do the videos is to support students that don't have a calculator at home. And so that's hopefully helping out those that don't. Let's try maybe this one. This one looks kind of challenging. So let's take that second number and divide by that first number, 16,384. And let's divide that by -65,536. And so it looks like that's 1/4 as a negative. I'm kind of dividing by 4, and the signs are changing over and over there. So let's build our formula. A sub n would be that first value times -1/4, and then the n minus 1. So I'm satisfying this part, write an equation. And now I want to find the 9th term by basically replacing the n value with 9. And so I know I'm using 9 for all of these. Each type of question usually asks for a different future term, but for these directions, all of these is asking me to find the 9th term. So negative 65, 536, multiplying that by negative 1 over 4, and now I'm looking for the 9th term, which actually is kind of simple. It actually comes out to just be negative 1. All right, so I want you to try a few others that are in this section to see if that's something that you're tracking with. And we can check your work on Tuesday. No school for Martin Luther King on Monday. So now it says a ball is dropped from a height of 500 meters, and the table shows the height of each bounce. So write a rule to represent the height of the ball after each bounce. So the first bounce is 400, the second bounce is 320. So this is kind of my sequence value. And so I know they gave you 500, but again, if they want on the 6th bounce, this is the first bounce, so this would be the first number. So that you do want to pay close attention to that kind of stuff because you want to make sure that you do have the first number correct. But I think based on this looking for the 6th bounce, if this is the first bounce, then I think we're good with 400 being the first value. So we're going to write a rule. Again, writing a rule involves a quick little formula. The first number multiplied by n minus 1, and then, the first number multiplied by the common ratio, and then n minus 1 for the exponent. So it looks like my first number is 400. But I may need to divide that second and first number, 320 divided by 400. This will allow me to see that basically I'm multiplying by 0.8, or I'm getting 4/5 of what I had previously each time. And so I want to put 4 over 5 in here. You could also put 0.8. It's the same thing. It wouldn't matter really when you calculate it. And then n minus 1 for the power. So that was the first part. Write a rule to represent height of the ball after each bounce. So you need n in the answer. And now, this is our n value that they want us to replace in our equation to jump straight to the height at the 6th bounce instead of continuing this process of multiplying by 4/5 until we get to that 6th number. That's what's great about having the equation. So let's jump into the equation, and I'm doing 6 minus 1. So it looks like the height of the ball on that 6th bounce is 131.072. I'll look at the units. It looks like it's in meters. There we go. All right, hopefully this video was helpful. Have a great long weekend. Bring your homework on Tuesday, and see you later. Peace.